All right. So let's tackle electrostatics. So in this scenario, we have a sphere N with the charge of minus 30 microcoulombs, which is placed on an insulated stand. Then another sphere M with the charge of minus 20 microcoulombs. Now this one is hanging on an inextensible string from a horizontal beam and is at a distance of 80 centimeters from sphere N as shown in the diagram below. Okay, so let's convert first the distance to SI unit. So 80 centimeters to meters will be equal to 80 over 100, which will be 0.8. Yeah, this is equal to 0.8 meters. Okay, so that's the separation between the two charges. All right, so now in 7.1, we need to state Coulomb's law in words. 7.1. So I'm just going to first write the mathematical expression of Coulomb's law. So F is equal to K Q1 Q2 over R squared. So in words, this simply means that the electrostatic force between two charges is directly proportional to the magnitude of the product of the charges and inversely proportional to the square of the separation distance between the two charges. So that's Coulomb's law. Okay, then in 7.2, we need to draw a leveled free body diagram for sphere M. All right, so sphere M is the sphere that is hanging. This one. Okay, so this sphere, since it is hanging, so it is possessing the weight force and also the tension which is applied at an angle. Okay, let me draw this free body diagram here. So we have the weight force, then the tension which is applied at an angle, and the angle is not given to us. Then the third force is the repulsion force, Fe, which is applied by sphere N to sphere M, because those spheres have negative charges, so they are going to repel each other. Like charges repel each other, and like charges attract each other. So it's going to be in the east direction. So that's the free body diagram for 3 marks. Okay. Then 7.3. 7.3. We need to calculate the magnitude of the electrostatic force between the two spheres. All right, so using Coulomb's law. So F is equal to K Q1 Q2 over R squared. Okay, then K is 9 exponent 9. Then Q1 is 30, and micro means 10 exponent minus 6. So we need to convert that charge into scientific units, SI units. Then the second charge is 20 exponent minus 6. Then the separation is equal to 0.8 meters all squared. So if you note here, I didn't put the negative sign. So we don't put the sign of the charge in electrostatics, because we know if the size of the charges are not the same, then that means that force is the attraction force. Then if the charges are like charges, then the force will be repulsion. So I'm just going to write here repulsion, because the nature of the charge is the same. So the charges are all negative. So I'm not going to put negative and negative there. All right. So now we can use our calculator. So to calculate the final answer, then 20 exponent minus 6 over 0.8 all squared. So the final answer will be 8 comma 4.375 newtons. Okay. Repulsion. All right. Then 7.3.2. So that was 7.3.1. Then 7.3.2, we need to calculate the tension in the string if the mass of the sphere M is 90 grams. Then before we do any calculation, we need to transform the given mass into SI unit. So 90 grams over 1000 will be equal to 90 over 1000 will be equal to 0.09 kg. How are we going to get this tension? All right. How are we going to get this tension? Okay, let's go back to our free body diagram. So what I'm going to do here, we know when the force is applied at an angle, so we split that force, we resolve that force into its component. So here we're going to have the vertical component and the horizontal component. So the vertical component will be opposing the weight. Okay, let me just write this horizontal component here. So this will be Tx. Then this will be Ty. Then now, since I have written the components of the tension, okay, I can wrap it, because those two components are equivalent to tension. Okay, I'm just going to leave that tension over there. All right, it's fine. It's fine. Okay, so now this sphere is not moving. So the acceleration in the x direction and in the y direction is 0. So I'm going to apply Newton's second law and determine the F net in the y direction and also in the x direction using the components of the tension. This should be T. Okay, so let's first start with the x direction. So F net in the x direction will be equal to ma, but acceleration is equal to 0 in the x direction. Therefore, my F net will be the electrostatic force, which is applied by sphere N on sphere M. This one, then that force is opposed by the x component of the tension. Then when you add them, they are equal to 0 because they are going to cancel each other. Hence, there is no acceleration in the x direction. Therefore, this electrostatic force should be equal to the x component of the tension, which is equal to, we calculated the electrostatic force there. It is 8,4375. 8,4375 newtons. So that's the x component of the tension. All right. Then now we're done with the F net in the x direction. Now let's calculate the F net in the y direction. So again, it is 0 because there is no acceleration in the y direction. Then my F net in the y direction, it's the tension, which is opposed by the weight, the y component of the tension. So it's Ty, which is opposed by weight. This is equal to 0. Therefore, Ty should be equal to W, which is equal to mg. Then the mass was given to us to be 0.09 kg. 0.09 kg times 9,8. That will be equal to Ty times 9,8. All right, that is equal to 0.882 newtons. So that's the y component. So we have the x component of the tension and the y component of the tension. So we need to calculate the tension itself. I said earlier, those two components, when you add them, they are equivalent to the tension. All right. Okay. So I'm just going to wrap this thing over here. So now what I'm going to do, I'm just going to move this y component and put it here without changing its magnitude and direction. I just change the position of the vector. So it is still the vector quantity because the magnitude didn't change and the direction didn't change. So now I have successfully formed a closed triangle, a right-angled triangle. Therefore, I have Tx and Ty and theta here. All right, but we don't need that theta, so I can just remove it. Okay, but if you know T, now we can apply Pythagoras theorem because this is a right-angled triangle. So according to Pythagoras, the square of Ty plus the square of Tx should be equal to the square of T. Now T squared should be equal to Ty squared plus Tx squared by Pythagoras. Then Ty is 0.882 all squared. Then Tx is 8,4375. 8,4375 all squared. This should be equal to T squared. Therefore, T will be equal to the square root of that. Therefore, our tension will be equal to 0.882 all squared plus 8,4375 all squared. Then the tension should be equal to 8,483 newtons. All right. Then we are done with question 7. So for 12 marks. Then question 8. Question 8. Question 8. So in question 8, let me read question 8. So question 8, we have two small spheres, A and B, with A having a charge of 5 nanocoulombs and B having a charge of -4 nanocoulombs respectively. And they are placed at a certain distance from each other in a vacuum as shown in the diagram below. And then in 8.1, we need to define the term electric field. Okay, so we have two charged spheres. The other one is negative and the other one is positive, so they are going to attract each other. Okay, then we need to define the electric field in words. So what is electric field? Electric field is a region in space where an electric charge will experience a force. Therefore, if you place an electric charge in a certain region and that electric charge experience a force, that means that region is the electric field. Okay. Then 8.2. We need to draw the electric field pattern between sphere A and sphere B. All right. Sphere A and sphere B. Sphere A is positive and sphere B is negative. And we know since those two charges have different signs, so they are going to attract each other. And we know that electric field terminate from positive to negative. Therefore, this is our positive. Okay. Then this is our negative. Then they are going to attract each other. So the electric field is going to move from positive to negative. Like that. So that will be electric field patterns. All right, so all right. Okay. So we're going to have something like this. 8.2. Got remarks. Then 8.3. Now a point P is a point left of sphere A and sphere B. Okay. So we have sphere A, then we have sphere B. Okay. Then we have a point on the left of sphere A and B. So, all right. Then point P is at a distance r from sphere A, and sphere A is at a distance of r from sphere B. So this distance is 3r. The distance between, okay, let me put A here and B here, then P there. Okay. Then the net electric field at that point there. So innet at that point is equal to 4128 Newton per coulomb, and it is in that direction, to the west, in that direction. All right. Now we need to calculate the value of R. How are we going to calculate this? How on earth are we going to solve this? All right. So we are given the net electric field at point P. That means at point P, we must have a positive test charge. So instead of that point, I'm going to put a positive test charge there. Okay. Okay. Let me use red, okay, for that positive test charge. All right. Okay, now we need to find the electric field. Okay, the net electric field at that point, which is given to us to be 4128 to the west. All right. So now sphere or this test charge at P interact with this charge at A. So since they are like charges, they are going to repel each other. So this sphere A is going to push this charge. So this sphere A is going to push this test charge in that direction. So it's going to repel it in that direction to the west. Okay. So the interaction between the two. So the test charge at P is going to experience the repulsion force to the west. So let me try free body diagram. So this is the test charge. So the test charge is going to experience the electrostatic. Let me write the first diagram here so that I can give myself enough space. So it's going to experience this force, the force PA, to the west. Then now let's check the interaction between test charge at P and sphere B. So sphere B is going to attract that test charge because they have opposite sides. So the nature of the charge is not the same. So we're going to have this force, the force PB. So A repels the test charge, B attract the test charge. So this is our force diagram. Those are the forces that are acting on the test charge. So now we know force and electric field are vectors. So always the force and electric field point in the same direction. So now I can replace this force by electric field, because remember we define force by QE, and we know Q does not have it's a scalar, so it does not have direction. So the force will take the direction of the electric field, because those are two vector quantities. Therefore, if the force is in that direction, that means the electric field is also in that direction. So now I can replace this force by E, because the direction is the same. So this will be E PA, then this will be E PB. Okay, but what is EPA and what is EPB? Then EPA plus EPB is equal to 4128. Okay, so what I'm going to do, I'm going to take, okay, we're given the directions here. So, and I'm going to, okay, it's fine. So this is east, this is west, this is north, then this is south. This is south. So I'm going to take this direction as positive, then this direction as negative. Then since for the net electric field is to the west, so it's going to be positive. Then EPA should also be positive, because it is pointing in the west direction. Therefore, this one should be negative, EPB, because it is pointing in the east direction. Then what is EPA? It's going to be KQ over R squared. Then KQ over R squared. This will be equal to 4182. but this will be charge A, then this will be charge B. Okay, what is K? K is 9 exponent 9. What is QA? QA is 5 nanocoulombs. 5 times 10 to the power minus 9 to change to scientific units. Then separation between charge A and point P, it was given to be R, so it's R. So now we need to square that R. So R squared. Then minus K 9 exponent 9. Then charge on B. Then sphere B, it's minus 4 coulombs. But okay, it's 4 times 10 to the power minus 9. Then the separation between point P there and this charge is 3R plus R, which is 4, which is 4R. Now, note, I didn't put that negative sign there because I have accounted it here. When I used the free body diagram to determine the direction, so I'm not going to put the negative sign and positive sign of the charges in my calculation. Now we need to solve for R. Then let's type this in our calculator. 9 exponent 9 exponent 9 times 5 exponent minus 9. So it's going to be 45 over R squared. Oh, I forgot to put this 4182. Okay, minus then 9 exponent 9 over times 4 exponent minus 9. This will be 36 over 4R squared. What is 4R all squared? 4R all squared will be equal to 16R squared. This will be equal to 4182. All right. Okay. So now we need to solve the left-hand side. Okay. Then what is 45 over 1 minus 36 over 16? This will be equal to 171 over 4R squared, which is equal to 4182 over 1. Then I can cross multiply. Then 171 will be equal to 4R squared times 4182. Then I shall divide by 4 both sides. Then, okay. So I'm going to have 171 over 171 is equal to 4 times 4182, which is equal to 16728 R squared. Then divide by 16728. 16728. Then R squared will be equal to 171 over 16728. Then take the square root both sides. Therefore, R should be equal to 171 over 16728, which is equal to 0.101 meters. Then we are done. So that's it.